Hi students, welcome to Physics with ER channel. So today we are going to discuss regarding the concept of pressure. The thrust exerted by liquid at rest per unit area normal to the surface in contact with the liquid is called pressure of a liquid. Here this is a liquid, so which we can take it, which is in contact, and here which has been exerted per unit area normal to the surface, perpendicular. So based on that, which you can tell it as the total force exerted by a liquid on any surface in contact with it, which I can call it as thrust of the liquid. So in simple form, so pressure P is equals to force by area, which we can tell it. So P is equals to F by E. With the help of this, pressure P is equals to force by area, the SI unit, which you can write it as, which is nothing but, so force by area. For force, the SI unit is Newton. For area, unit is Newton per meter square. So by default, the SI unit of pressure, which you can be used as, which is nothing but Newton per meter square. So CGS unit of pressure is a dyne per centimeter. For force, CGS, centimeters, gram and second in terms of that. For force, unit is dyne. For area, unit is centimeter square. So under certain conditions, which we can use, instead of Newton per meter square, we can use it as a pascal. This pascal, which is denoted by PA, which is equals to 1 Newton per meter square. So dimensions of pressure, this is a m power 1, L power minus 1, T power minus 2. So if you know the dimension formulas for force and area, so which have been taken. For force, dimension formula is nothing but, so m power 1, L power 1 and T power minus 2. By area is nothing but L square. If this L square, if it move upwards, we are going to get it as here m power 1, L power minus 1, T power minus 2, which we are going to get. And pressure at a point in a fluid is independent of direction. With the help of this, pressure is a scalar quantity, which we can tell it. So regarding further concept, so which you have been taken, so density of a fluid. So apart from pressure, there is another quantity indiscernible in describing fluids. So in describing the fluids, that which is nothing but density. This density, which is denoted by rho. This density value, which is denoted by rho. For fluid of mass m occupying a volume v, under that condition, which we can write it as density rho is equals to mass by volume. In simple form, rho is equals to mass by volume, or m by v, which can be used. So SI unit of density. This SI unit of density is nothing but kg per meter cube. For mass, we can use kilogram, kg. For volume, we can use it as a meter cube. So kg per meter cube, so which you are going to obtain. So CGS unit, that CGS unit which have been taken, mass we can measure in terms of grams, and length which we can measure in terms of centimeter cube. So based on that, a gram per centimeter cube, which we can tell that. It is a positive scalar quantity. So for the topic, so which we can take it as pressure due to a fluid column. So how much we can tell that. For this, they have been taken it as, these are the assumptions, so which they have been taken. Rho represents the density of liquid, A represents area of cross section of cylinder, and H represents height of the column. So under this condition, so which we can tell it as weight of liquid column. Weight in general, so how we can tell that, so which is nothing but weight W is equals to mg. But we don't know the value of mass, but we know density rho is equals to mass by volume. With that, m is equals to, we can write it as, which is equals to rho into v. That is volume into density into acceleration due to gravity. So volume is equals to A into H. For this liquid, area of cross section is A, and height of the liquid column, which you have been taken it as a H. So weight of liquid column, A into H into rho into G, which we can write down. So with the help of this, so pressure, which we can write it as weight of the liquid by weight of the liquid by cross-sectional area. So this is a formula which we can be used. With the help of this, weight of the liquid is nothing but AH rho into G by cross-sectional area which have been taken it as A. So AA gets cancelled. That pressure P is equals to H rho G, which we can get it. So pressure is nothing but in terms of a fluid column which you have been taken it as H rho G. So the pressure due to a liquid column is directly proportional to. So first it depends on which you have been seen that depth h and density and acceleration due to gravity. Based on these factors, so which it can be depends. So here we have not been discussed regarding this atmospheric pressure. This atmospheric pressure is nothing but, so this is a standard value P naught, which is equals to 1.013 into 10 to the power of 5 pascals. Regarding this in detail, which we can be discussed. So P is the pressure due to the liquid. So under this condition, then what's the total pressure which have been taken? Atmospheric pressure plus P. So P naught plus pressure P, which you have been put as H rho G. So total pressure is nothing but which you have been put it as, so P naught plus gas pressure. This H rho G, which we can call it as, which is nothing but gas pressure. The excess pressure P minus P naught at a depth is called gas pressure. A gas pressure at that point. It is important for MCQ, or even they can ask for 2 marks question. Dear students, please subscribe my channel, like it, and then share to your friends. Thank you for watching. Have a nice day.